Okay, so in this video, we're going to learn the rules of rational exponents. These rules are very important in order to perform arithmetic operations with rational exponents. We want to make sure we have a good handle on these types of things. So we're just going to spend a few minutes going over the rules, okay? And I will spell them out clearly for you here. And these are the things that you're going to need to really watch out for. That's not difficult. You just have to get used to some of the rules. And once you are, once you start realizing what you have to do, once you, acclimate to the rules, then you just apply them every single time with every problem, okay? So the very first one I want to talk about is called the negative exponent rule. And I kind of mentioned this in one of the previous videos, but like I said, we'll go over everything here. So I'm going to create like a little chart or a little table, if you will, all right? And that way you can understand what I'm doing, okay? So here we go, all right? The very first one is called the negative exponent rule, all right? So let me write that out, okay? Write it over here, negative exponent rule. Okay. All right? Okay. And what that's saying is that if you have x raised to a negative exponent, and we're just going to designate it as n. Okay, now you can use any variable you want, it doesn't matter. Okay, that's equivalent to the reciprocal of 1 over xn. When you take the reciprocal, okay, don't forget, the n becomes positive, okay? That means the exponent n turns into a positive number. And we got to make sure. So that's the equivalency of any base raised to a negative exponent. You can write it as that, or you could enter it on your calculator as 1 over x to the positive n power. Okay, it's equivalent. All right? So that's the first rule. And we're just going to discuss rules here, or then we'll do example problems. Okay? Actually, you know what? I'm going to incorporate a small example. Okay? So let's go ahead and do that. All right? So here we go. So an example would be 2 to the negative third power, and that's equivalent to 1 over 2 to the positive third power. And then when you evaluate that, 2 to the third power is 2 times 2 times 2, which is 1 over 8. Okay? And that's how you would evaluate that. Okay? The next rule is called the product rule. All right? And that simply states that when you have two bases and you're multiplying two bases with exponents, okay, the equivalency is you're just going to add the exponents. Okay? So again, the x represents the base. They have to be identical. Okay? These have to be identical. All right? Before you can add the exponents. If they're different bases, then you can't add those exponents. So it's really important. So an example would be like, let's say you had x to the 5th power times x to the 7th power. The equivalency is you add 5 plus 7, and then you get x to the 12th power. All right? So it's a pretty simple rule. The next one is called the quotient rule. Quotient meaning dividing, right? And that will occur when you have a division of two exponents, okay? So the rule is that when you have the same bases and you're dividing the same bases, you can take the exponents and subtract them, okay? So an example of this would be, let's say you had, I don't know, x to the 10th divided by x to the 5th power. Then the equivalency is 10 minus 5, which is x to the 5th power. Just subtract the exponents, all right? And that's all you do for that. The next one is called the power rule. And the power rule tells you, by the way, this is products. This involves products, right? Which is multiplication. You get a product when you multiply something. Okay? So this is going to occur when you have, let's say you have x, y, all right, and you raise that to the n power. That's equivalent to x to the n power, y to the n. You raise everything in the parentheses to that same power. Okay? So if you have something like xy raised to the 4th power, then that's equivalent to x to the 4th times y to the 4th. Okay? Just another way of rewriting it. And then, of course, the last one I want to mention is the power rule, and that involves quotients. And you're going to get a quotient when you divide something. All right? So an example of that would be, let's say you had x over y raised to the n power. That is equivalent of raising everything in the parentheses to that same power. Okay? All right? So, and then of course, if you have this, let's say you had, I don't know, x over y raised to the negative nth power, then what you can do is you can do the reciprocal and then make the exponent positive. That's also equivalent, as long as y is not equal to 0. Okay? Because anything divided by 0 is 0. All right. And if you have 0 over here, x over 0, that becomes undefined, so you won't be able to do that. So x cannot be 0 in this situation. All right? Okay, so those are all the rules that you want to keep in mind. All right? So let's go to the next slide and do our first example. Okay? So let's say you had x to the 1/2 power, and you're going to raise that, to the 1/3 power. Okay, when you do that, then that's equivalent to 1/2 times 1/3. And when you multiply fractions, you multiply straight across. So 1 times 1 is 1, and 2 times 3 is 6. So you can have x to the 6th power. And that's all you do. You don't have to do anything else after that. Let's say you had x to the 1/4 power times x to the 7/4 power. Remember, you're multiplying the same base. So what do you do with the exponents? You will add them. Now remember, when you have fractions with the same denominator, all you're going to do is add the numerators. 1 plus 7 is going to be x to the 8 over 4. And then, of course, 8 divided by 4 is going to be 2. So you want to simplify that fraction. So your answer is going to be x squared. Okay? So let's say you had an example, x to the 1/5 times x to the 1/3. I'm sorry, let me come out right. That means you're going to take 1/5 and then you're going to add 1/3. So as a little footnote, when you have fractions with different different denominators, you're going to have to find a common denominator. So the common denominator between 5 and 3 would in fact be 15. Okay? So as a little footnote, okay, over here, you need to multiply this by 5 and this by 3 in order to get the denominators to be the same. So that's going to be 3 over 15 plus 5 over 15. I'm just multiplying all the numbers. And that's going to give me 8 over 15. Okay, so that's going to be equal to x and the 8 to the 15 power. And that's going to be your answer, okay? All right, let's do a couple more. Let me see what example, that was number 3, right? So number 4. So let's say you had x to the 1/4 power divided by x to the 3/4 power. When you're dividing the same base, you subtract the exponent. So 1/4 minus 3/4. That's going to give me 1 minus 3 is minus 2 over 4. But if you reduce that, that is equivalent to minus 1 over 2. And then you can go ahead and write that as the reciprocal, which turns into x of 1/2 power. So you don't want to leave your exponents negative. You want to simplify them by applying the rule. You're applying the negative exponent rule by doing the reciprocal. So technically, this is your final answer. Okay, let's do this one. Remember, we have to write these in exponent form. So the cube root of x is equivalent to 1 over 3. Remember, the root becomes the denominator and the invisible exponent 1 becomes the numerator. Okay, I'll write the 1s there. Times, again, it's 1 over 4. And when you do that, you're going to add the exponents, 1/3 plus 1/4. So when you do the arithmetic, okay, you need a common denominator. So we'll do that over here. 1/3 plus 1/4. Common denominator is going to be 12. So I'm going to times this by 3 and this side by 4. And when you rewrite it, it becomes 4 over 12 plus 3 over 12. And that gives you 7 over 12. So my final answer is x to the 7 over 12. Okay. Okay. I just want to show you a couple more examples and we're almost finished. Okay. So let's say you had x to the 1/2 and you want to multiply that by x to the 3/2 plus x to the 4th power. Well, if you remember, anything outside of the parentheses is the distributive property. So we're going to use the distributive property Okay. All right, so that's what we need. That means we're going to have to take this and multiply it by this and by that. So what we're doing is we're doing x to the 1/2 times x to the 3/2 plus, and then we're doing x to the 1/2 power times x to the 4th power. Can you see that? All right. So remember the rules of exponents. When you get to this point right here, we need to add the exponents because you have the same base. Plus, same goes for here. 1/2 plus 4. All right? So to making sure we're understanding our fractions, if you have 1/2 plus 3/2, the denominator is the same. So all we're doing is we're adding the numerators. So 3 plus 1 is 4 over 2. 4 divided by 2 is 2. All right? We want to make sure we're super clear on that. Okay? So x to the 2nd power. Okay, this gets simplified to x to the 2nd power plus, and now we do the same thing over here. We have 1/2, we're adding 4 over 1. Common denominator needs to be 2, so we're going to multiply that whole right fraction by 2. So now we have 1/2 plus 8 over 2. That's going to give me 9/2. All right? So x to the 9/2. And then we can't, yeah, okay? So that's your answer, okay? And we're not adding the exponents because there's no multiplication here. It's just x squared plus 9/2. So this would have to be the answer. All right? All right, let's do another example. And we're going to do the distributive property here. So when we do that, that's going to be x to the 1/3 times x to the 4/3. Then we have minus. And then we're going to distribute here. So then you have x to the 1/3 times a negative 2x. All right? Then we're going to multiply this. So that's plus x to the 1/3 times x to the 5th. All right? Okay, so let's simplify this. All right? The first one is the denominators are the same, so we can just go ahead and do this. It's going to be x. 1 plus 4 is 5 to the 3rd power. All right? Then it's minus, and then we have x to the 1/3 times times negative 2x. Sorry. Okay? So remember, there's an invisible exponent of 1 over here. So when we do that, okay, don't forget it's going to be 1/3. Actually, let me do it in a different color. We're just doing the arithmetic here. Okay, I'll do it at the bottom. So we have 1/3 plus x to the 1st power. So we're adding 1 over 1. All right? So when we do that, okay, common denominator needs to be 3. So we're going to, whoops, I'm so sorry. 1 over 1. Common denominator needs to be 3. So I'm going to times this by 3. And that's just 1/3 plus 3 over 3. So that'll give me 4/3. Okay? So that becomes negative 2x to the 4/3 power. Okay, and then it's plus, and then the arithmetic here is going to be 1/3. Again, we can do that over here at the bottom. Okay, so 1/3 plus 5/1. Okay. Okay, we need a common denominator, so we're going to multiply the rights. Whoops, that's not working. Times 3. That's equivalent to 1/3 plus 15/3. And that's going to give me 16/3 when you add the numerators, okay? So this becomes x to the 16/3. And this would be my final answer. So you just have to be good with basic arithmetic, common denominators, and things like that. Just have to be a little mindful about things like that are going to come up. Other than that, the algebra is pretty simple, pretty straightforward. And I hope that this video allowed it to be that straightforwardness, okay? So thank you so much, and I'll see you in the next video.